Hello students, definite integral is one of the most important chapter for entrance examination like JEE Main and JEE Advanced or such contemporary examinations. You may get question from any chapter, you may not get question, but you must get question from the definite integral. Not even one, you may get more than one question. So in this video, I'll give all the important formulas and its application in one place such that in short term preparation, in short time preparation, this video is very helpful to you. So let us start. First of all, what is the definite integral? So in one line we can say definite integral is the area under the curve with the proper sign. It means above the x-axis ये होगा positive, below the x-axis ये होगा negative. For example, this is the x-axis, above the x-axis the curve, the shadow of the curve on the x-axis, actually area, whose area? Shadow of the curve on the x-axis, its area. This area is positive and below the x-axis this area is negative. For example, if we see the sin x curve, in case of sin x curve, we are saying that, just a minute, in case of sin x curve, we are saying that this is pi 0 to pi and this is pi to 2 pi. Between 0 to pi, sine curve is above x-axis. It means this is the positive and इसका नीचे होगा negative. So if we give the definite integral 0 to 2 pi sin x, answer should be 0. Answer should be 0 because upper half is cancelled by lower half. By the way, remember one thing, this 0 to pi, the area is 2. This area is 2, this area is also 2. But in the area examination, when in entrance examination area is coming, find the area bounded by x-axis and the side curve. Answer will be 2 plus 2, 4. But whenever question is coming, find the integral 0 to 2 pi, answer is coming 0 because upper half is cancelled by the lower half. Okay, now I am going to the next part. Let's come to the property of the definite integral. So first, these are basic properties. First property, a to b fx dx equal to a to b ft dt equal to a to b fp dp, whatever, name is not the problem. Second is the a to a fx dx, it means it is a point. A to a fx dx, it is a point. So iska area to obviously it will be 0. And third property, a to b fx dx equal to minus b to a fx dx. What is this? Yeah, reversibility property, reversibility of the light rays. And this number 4, this a to b, a to c, c to b. Actually this is called the partition property. We can partition the area. Suppose a to b it is there. So we can keep one partition so that a to b fx dx can be a to c. Generally this particular property is utilized only when there is some problems, like at pi by 2 there is a tan x. So tan x has a problem, it is a undefined, or you can say whatever, asymptote goes to the infinity, whatever you say. So under this case we can just make the number of such partition. Here is also it is the same thing. Now this is called the king property and it is extremely important. This property is extremely important, which is called the king property. The king property is a to 0 to a fx dx equal to 0 to a f of a minus x dx. Yes, it is really king because maximum case, in maximum sense this property is being utilized. And second is the a to b fx dx, a to b f of a plus b minus x. So this is the same thing, this is also the king property. So one example I am showing you because it is extremely important. So just I am showing you one application of the king property. Suppose this value is I. So I equal to, this is I. Therefore I am applying the king property, root over of cot pi by 2 minus x. In this case it is pi by 2, a is pi by 2 here. 0 to a, here it is pi by 2 as the a. Therefore we can write this as root over of cot pi by 2 minus x is tan x by denominator cot is tan, tan is cot. So this is I, this also I plus I, 2i. 2i numerator denominator is getting cancelled and we are getting tan x plus root over of cot x. Similarly numerator also root over of tan x plus root over of cot x, and they are getting cancelled. 0 to pi by 2, that is x. Nothing is there, this is 1 So this is x, upper limit and lower limit. So pi by 2. So 2i equal to pi by 2, I equal to pi by 4. So this is the application of the king property. One more application of the king property which we have done previously. For example, this property application a to b fx dx equal to a to b a plus b minus x. It's one application I am showing. So here it is a to b dx by 1 plus cot x, root over of cot x. Root over of cot x, if we just calculate, we are getting in terms of sin cos, we are getting this thing. Now a plus b minus x, actually 30 plus 60, 90 minus x. So we are getting here sin 90 minus x is cos x, cos 90 minus x, and denominator is coming same, I plus I 2i, 2i equal to same thing, same as this previous case, they are getting cancelled. So dx, dx integration x, so upper limit minus lower limit, and we are getting the result. Okay, now I am going to the next. And this property, property number 8 is very important. In this property, minus a to a fx dx, it has three formulas. First formula is general formula 0 to a fx plus f of minus x, and second formula, if the function is the even function, then 2 into 0 to a fx dx, because for even function y axis is the axis of symmetry. So left of the y and right of the y, instead of doing so much, we can do just 2 into 0 to a. And for odd function, suppose for odd function, we know that odd function is symmetry about the origin, so upper part is cancelled by the lower part. That is why for odd function minus a to a fx dx is coming to be 0. And remember one thing, this property I am showing you one application. Under what condition we can use this property? This property under what condition we can use? Generally, remember one thing, in this type of cases we can use this type of property. In general case, I am telling you about the 90% case. Other 10% case, you have to apply according to the situation. For 90% case, remember one thing, whenever this type of sum is there, so a to the power x, e to the power sin x, 2 to the power x, 3 to the power x, under this type of cases, we can apply these properties. I am showing the application of this property. So in this case, it is coming to be 0 to pi minus a to a, this is minus a to a, so 0 to a, 0 to pi, so fx is cos square x by 1 plus a to the x plus f of minus x, so cos square minus x is cos x. So we can write this as cos square x by 1 plus a to the power minus x. Now, if we calculate here, we are getting 0 to pi cos square x dx, and this is coming to be pi by 2. So if you remember this, because whenever the question will be coming in the entrance examination, we have no time, we have short time. So under this case, remember one thing, once again I am telling you, under this case, this type of cases, identify this type of cases, one denominator 1 plus a to the power x, 1 plus e to the power sin x, 1 plus suppose 1 minus whatever, 2 to the power x. In this type of cases, we have to apply. In 90% cases, we have to identify this property you have to apply. And remember, more important thing is that while moving further forward, I will show you some important formulas application. 0 to pi cos square x. So we can apply that if we multiply 2 cos square x and 2.5 outside, 2 cos square x is 1 plus cos 2x, and then we can calculate. But instead of doing so much, better everybody, if we can learn it, if we can remember this in while proceeding, I will show you this formula, so that if you can remember, if you can learn, in the long run, you will get the result. And in examination, whenever, because in examination, lot of questions are based on integral, indefinite integral, as a whole, definite integral, differential equation, area, application of integral, and in all other, in number of chapters, we can have the integral. So in these basic things, if we can remember, we can get the result of this. Now, minus 1 to 1 log of x plus root over of x square plus 1. So in this case, one more application. So this for the even odd case I am showing you, so that this type of formula becomes very much comfortable to you. So here in this case, fx I have taken just multiply, divide by the conjugate, and we are showing that in this type of log case. And everybody remember one thing: whenever this type of sums will be there, this type of log case will be there, this should be the odd function. If you can remember, if you can identify for the examination hall, it becomes more easier way to solve the sum easily. So this is coming to be 0. And this formula is another very important formula, and for this formula, everybody remember one thing: this particular formula is called the Queen property. This is the Queen property. It is another important property. This property is another important property. Remember this. So let us proceed. I am solving one very important sum, which you have to keep in mind the result of this sum. And everybody, in this case, in this video, I will show you some results, and if you can remember this result, so it will be very fast. You can solve the sum very fast, because whatever sums which I will show you to learn, or which I tell you to learn, if you can learn it, you can solve the sum very fast, very faster. One very important sum: 0 to pi by 2 log of sin x. Answer is pi minus pi by 2 log 2. You have to learn it, you have to remember this. And how it is getting solved, I am showing you. So 0 to pi by 2 log of sin x. So I am using the King property. So log 0 to pi by 2 log of sin pi by 2 minus x. So sin pi by 2 minus x cos x. It means 0 to pi by 2 log of sin x plus 0 to pi by 2 log of cos x, log sin x plus log cos x, log sin x cos x. Now after using log sin x cos x, if you multiply by 2, so log sin 2x by 2, it means log sin 2x minus log 2. So finally, where it is there? Log sin 2x minus log 2. Now if we take 2x equal to t, everybody, I can remember this because I have done, I think, 1000 times these sums, this type of sums. So I can remember this. So 2x equal to t. So if we take 2x equal to t, then the limit will be changed 0 to pi. Now we can apply the property number 5. It means we can apply what is called? That is the Queen property. We can apply the Queen property. By the Queen property, this thing, this is the pi. Now by using the Queen property, this is coming pi by 2, and we have taken 2x equal to t. This is t, and sin x dx equal to sin t dt, because name is not the problem. Now we can put it here. Therefore 2i, here it is I. So log sin x, log sin t dt, and finally 2i equal to I minus pi by 2 log 2. So I equal to minus pi by 2 log 2. Remember this particular sum acts as the intermediate step of number of sums. Now I am going to the next. And everyone will discuss the most probable sum, most probable formula for the entrance examination, mainly for JEE Main, JEE Advanced examination. This is the Leibniz rule. So Leibniz rule is very important. It has two rules. One rule for the JEE Main examination, mostly important. So the rule is d dx of the definite integral. D dx of the definite integral, what is there? Derivative of the upper limit into function of upper limit minus derivative of the lower limit into function of lower limit. So if we apply this formula, let's see here. So we have to do the derivative. So we can write this as f dash x. So we can write derivative of upper limit. So 3x square into function of upper limit 1 by log of 3x square. Derivative of the upper limit, function of upper limit. Sorry, it is x cube. Just a minute. Derivative of upper limit, function of upper limit. Function of upper limit, in this case x cube, minus derivative of lower limit 2x into function of lower limit 1 by log of x square. Now finally apply 3x square by 3 log x minus 2x by 2 log x. So everyone, 3 cancelled, and if we take the log x common, we are getting what? Log x into x square minus x. This is the application of the Leibniz theorem. Next, one more application of the Leibniz theory. If phi x equal to this, then find phi rest. It means when to apply the Leibniz theory, when to utilize the Leibniz theory under the condition when there is at least in upper limit and lower limit at least one x is there. In maximum cases, we have to do the differentiation. In case of L'Hopital's theory also, whenever in the integral at least one is in upper limit and lower limit, that is x, we can apply the Leibniz theory. Obviously, it depends on some conditions. Next. So here also the same thing. So if we apply the derivative, so derivative of the upper limit, function of upper limit, and derivative of the lower limit, function of lower limit. So we are getting the result here. Now let's come to the mostly used formulas, which we have to keep in mind, which you have to learn, then we can get the maximized effect. Just see, 0 to pi by 2 sin to the power nx, 0 to pi by 2 cos to the power nx. Cos to the power nx, in this case this will be cos to the power nx actually, dx. Then in equal to n minus 1 by n, in minus 2, and in, and if we just go on reducing, actually this is the application of the reduction formula, but everybody, if we can remember all these formulas, our intermediate steps in the examination hall, it will be very much easier, very fast. So actually we have to remember this, in equal to n minus 1 into n minus 3 dot 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 dot, n divided by n into n minus 2 dot dot dot, and if n is the even number, we are getting this, last is the pi by 2, and if n is the odd number, this is coming this. One example, 0 to pi by 2 sin to the power 5x. It is sin to the power 5x. Whenever it is coming to be sin to the power 5x, it is an odd number. N is the odd number. So we will apply this formula. We will apply this formula, n minus 1 into n minus 3, continuation up to 2. So here it is coming, same value is coming, n minus 1 is coming what? 5 minus 1, 4, and n minus 2, 5 minus 2, 3. Similarly, in the denominator is coming n into n minus 2 up to 3. So this, the final answer is coming 8 by 15. Next, this is another important reduction formula with respect to the tan x, and this is very frequent for the examination as the intermediate step. Okay, so in, and this sum is actually getting solved by the by parts, so it is unnecessary, you can do of your own also. So this is the by parts formula, in plus in minus 2 equal to 1 by n minus 1. So in this way we can break. Therefore, just see one thing, one application I am showing you, in equal to 0 to pi by 4 tan to the power n theta d theta. So I8 plus I6. In this case in this case everybody, in, this is in minus 2, 1 by n minus 1. This is n, remember one thing, this is n and this is n minus 1. So maximum is the n. So in this case 8 is the n. So final answer is 1 by n minus 1. So this is answer is coming 1 by 8 minus 1, 1 by 7. Must remember these formulas. I am going to the next formula. There are some another formulas which are the reduction formula. If you can remember, it will be beneficial. So for tan, similarly for the cot, for sec theta also. So this is not so much used. Then also those who are thinking for the JEE advanced examination, those who are thinking for the ISI examination must learn these formulas, because you have it has a lot of application in this type of examination, this type of harder examinations. Next, Wallis formulas. This is also very important formula, 0 to pi by 2 sin to the power mx into cos to the power nx, and the formula is m minus 1 into m minus 3 into m minus 5 dot dot dot, n minus 1 into n minus 3 dot 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 dot, divided by, total divided by, it is actually divided, this is a printing error, divided m plus n minus 2, continuation, last is the k. And remember, if m and n are both even, then k equal to pi by 2, otherwise k equal to 1. So I am giving you one example, I have given one example so that the concept becomes clear for you. So 0 to pi by 2 sin to the power 4x into cos to the power 3x. So m and n are not both even. So finally we are getting k is equal to 1. Therefore let us see one thing, let us apply. So this is m, 4 is the, m is the 4 and n is the 3. Therefore m minus 1, m minus 3, m minus 5. So in this case 4 m minus 1 3 m minus 3 1, and for n minus 1 n minus 3. So in this case n minus 1 2 n minus 3. So not needed, and denominator is coming what? Here it is coming m plus 4 minus 2. So m plus n minus 2, like that. So 4 plus 3 7 7 5 3 1. So the final answer is what? So final answer is 3 is getting cancelled. So 2 by 35. In this way, and these formulas, this type of formulas are extremely important for the examination hall, because while proceeding the sum, while solving the sum, we have very good preparation, but somewhat what happens in the examination hall, that due to the formula, due to the just solving the formula, the time is done, time runs, otherwise we cannot remember the formula. So better everybody learn it so that we can save our timing. Next sum. And these are some type of sums, so that if you can remember, you can get the result, because these type of sums are regularly coming as the intermediate step in the while solving the sums. 0 to pi by 2 log of tan x, 0 to pi by 2 log of cot x equal to 0, 0 to pi by 4 log of 1 plus tan theta equal to pi by 8 log 2, like this. And these are very common for the examination hall, very common for the entrance examination intermediate stage. So using A and B, you must practice in your home so that you will get the maximum benefit of this, so that you don't have to solve the sum. Next, this is also some sums, like 0 to pi by 2 a cos x plus b sin x by cos x plus sin x dx. So equal to pi by 4 into a plus b. Suppose 3 sin x plus, for example, I am giving you one sum. For example, I am giving you one sum, so that you can remember. 0 to pi by 2 3 cos x. These are very common for the examination, like in differential equation. In differential equation, in area sums, these type of problems are very common, and if you can remember this, you can answer very prompt, very fast. Just see one thing, 3 cos x, suppose, plus 2 sin x total divided by sin x plus cos x. So we are getting what? Answer is pi by 4, 3 plus 2, 5. 5 pi by 4, like this. In this way, we have to keep in mind all these formulas. So in this way also same thing, 0 to pi by 2, it is the application of the king property. This is also the application of the king property. So we can do this here. Same thing, whatever we have done, that's the king property. So here I, using the king property actually, otherwise we can use this directly, we can use, not required to calculate even. Directly we can use. In this type of cases, we are getting the answer is 2 pi by 4. So this is the case of that. Okay, I am showing the king property. Actually, it is the application of the king property. In this way, you have to learn, so that in the examination hall, we can apply. This is tan x, and denominator is root over tan x plus root over of cot x. So I plus I 2i, it is getting cancelled. So I equal to pi by 4. Next, actually it is root 2, they have done mistake, it's a printing mistake, it's a root 2, 0 to pi by 2. So everybody, these are very common sums for the examination, because integration related lot of chapters are there. Integral calculus full is a chapter, full is a part which is integration related, indefinite integral related, definite integral related. So in this type of cases, if we can remember the formulas, we get very much benefited. Okay, so must remember this. For example, these formulas, for example, this formula is very important, this formula is very important, mainly this formula also must remember this. For example, I have given you one example, 0 to pi x dx by 4 sin square x plus 5 cos square x. Whenever you have to solve by the normal way, whenever we have to solve by the normal way, it will take your time. How? First of all, we have to apply king property, then I plus I 2i, then multiply by 6 square. Whenever we will multiply by the 6 square, we will get, again we have to apply Queen property 0 to 2 fx dx. In this way we have to just separate out 2, otherwise pi to pi tan x though pi to pi, it is 0 to 0 integral, it will be coming. So there are, it's a long, whenever it will be coming in the examination, if you go on solving this sum, it will take your timing. So if you can learn this, it will be 1-2 lines. Say this pi square by 2ab. So we can write this as pi square, answer is pi square by 2, a is root 4, 2, b is root 5. So answer is pi square, pi square by 4 root 5 in this way. Next, these are also important, and everybody, these sums, these two formulas are extremely important. Minus integration 0 to infinity e to the power minus ax cos bx, that is a by a square plus b square, and 0 to infinity e to the power minus ax sin bx, this is coming. Whenever it is cos, remember like this, whenever it is cos, this is a by a square plus b square. Whenever it is sin, then b by a square plus b square. You have to think like this. You have to remember like this. So for example, I am giving you one example here, 0 to infinity, and remember one thing here, e to the power minus ax, a is greater than 0. Here it is coming to be a is greater than 0. For example, here 0 to infinity e to the power minus dx cos bx, e to the power x cos bx, a should be greater than 0. It means here it is a, iska matlab a is here 3. Compare with the formulas, a is here 3. So here it will be coming a by a square plus b square. So we can write here 3 by a square plus b square, 3 square plus 7 square, like this. Here I have given one example, 0 to infinity e to the power minus 2x sin 2x plus cos 2x. So I have shown you the process, but actually we can apply that formula also. In this case we can write this as, first of all, first part we have applied the by parts, and keeping the second part unchanged, we are getting the result. Otherwise we can apply this formula, e to the power x sin bx, e to the power x cos bx. In this way also you can apply. I have shown you. The values are getting cancelled and we are getting the result. So everybody, these are very important formulas. I have given you in this video, I have given you the list of the formulas so that in one video you get everything. And everyone must subscribe this channel so that this type of videos, and you must comment so that if this type of videos whether is useful or not. Next, let us go to the next formula. And these are the list of the formulas which you have to keep in mind. For example, this type sum, I am showing you the example. Suppose 3 to 4 dx by, these type of sums are regularly coming under definite integral differential equation. So this is coming x minus 3 into 4 minus x. So everybody, this type of sums, if we calculate in the examination hall, it takes our full time, a lot of time, at least 3 minutes, 4 minutes, 5 minutes it will take. And if we can learn this, it becomes very much easier for us. We can save our time. Okay, so this is coming to be pi. So must remember and learn these formulas. Now let's go to the another list of formulas, and these are very important. These are very important, that box function. Just see one thing here, 0 to n box x, that is n into n minus 1 by 2. Remember this is extremely important, and 0 to n fractional x, this is coming n by 2. So number of ways we can solve this sum. We can solve by area method. Just I am showing you one method how this result is coming. Just see 0 to 3 fractional x dx. So we can write 0 to 3 fractional x is x minus box x. So we can write this as 0 to 3 x dx minus 0 to 3 box x dx. 0 to 3 x dx is x square by 2 upper limit and lower limit, and 0 to 3 box x, 0 to 1, 1 to 2, 2 to 3, like that. Otherwise we can apply this formula. Must remember everybody, extremely useful formula. This is, we can write, just I am showing you the way. So 0 to 1, this is 0, 1 to 2, this is 1, and 2 to 3, this is 2 dx. In this way, we can get the result. And in shortcut, in one line, this is the way. 0 to n fractional x, that is n by 2. Everybody extremely, very much effective formula it is. So in this case, answer is coming to be n by 2. So n is here 3 by 2. You must check it. This is the way how to solve this sum, and this is the shortcut method. Let's go to the next. Evaluate 0 to n. So we have done this n into n minus 1 by 2. So I have shown you the step by step method. So 0 to 1, 1 to 2, 2 to 3, all is the boxes, and final result is coming like this. So these formulas, these two formulas are very much important. Next. And 0 to n square box x dx is n into n minus 1 into 4n plus 1 by 6. This is another important formula. So everybody, do not leave all the formulas which is given, because I selected the formula by saying the just 40 years papers. Okay, so if you can remember this, you must get the positive result. Next. Zero to 1 x to the power m, 1 minus x whole to the power m, and the value is factorial n by m plus n minus 1. These formulas are generally utilized in JEE advanced examination. For JEE main, this is not so much important. This type of formulas, I will give the separate series for that. These type of formulas are very important for the JEE advanced type of examination, ISI type of examination. So everybody must keep in mind. Next. 0 to 2n pi box of sin x plus cos x dx equal to minus n pi. At least if you check last year's JEE advanced paper, you will see at least 2-3 question paper came on this. For example, this is one previous JEE advanced question, 0 to 2 pi box of sin x plus cos x. And if we solve by the normal way, and that is if we take the root 2 common, sin x plus pi by 4, x plus pi by 4 equal to t. So this is coming pi by 4 to 2 pi plus pi by 4. So pi by 4 to 3 pi by 4, 3 pi by 4 to pi to 5 pi by 4, 5 pi by 4 to 7. So this is a very big sum, very big formula. But if we apply this way, minus n pi, it means here n equal to 1. So minus pi is the answer. This is the way to solve the sum in one line. Now I am going to the next. And definite integral as a limit of sum and its application is another important part, and number of times it came in entrance examination. So let's see. 0 to 1 fx dx equal to limit n tend to infinity 1 by n r equal to 0 to n minus 1 or 1 to n f of r by n. This particular portion of the formula is very important. For example, if we apply limit n tend to infinity 1 to the power p plus 2 to the power p plus 3 to the power p dot p is a constant number. So first of all, what is the target? This particular type is very important. First of all, what is the target? Target is we have to get out of 1 by n. So n to the power p plus 1, I have taken 1 by n outside. 1 by n outside. Then we have to search for r by n. And just see one thing, this is r by n, and this r by n is converted to the x. Therefore, if we just keep it r by n means x. So final answer is 0 to 1 x to the power p. So everyone, not to calculate even. Remember one thing, we have to take out in this type of format, we have to take out 1 by n. After getting 1 by n, if whatever r by n form is there, just convert it to the x. Very important this is. I am showing you such one more example. Suppose limit n tend to infinity 1 by n square, x square 1 by n square, 2 by n square, x square 4 by, like that. First of all, everybody, what is the variable? The value which is varying is called the variable. Okay. So in this case, you see one thing, 2, 4, 1 square, 2 square, 3 square, 4 square. These are the variable. These are varying. First of all, you have to take it in outside. ओके हम लोग को पहले n को आउटसाइड में लेके आना चाहिए, n आउटसाइड, देन r इक्वल टू 1 to n, r by n is coming, this from this r by n is coming sec square r square by n square, r by n is x into sec square x. Okay, also here also, okay, just a minute, r by n square, it means r by n x into sec square x square, because r by n square it is. So x square, and finally we are getting the result. If we take x square equal to t, we will get directly the result. So this particular part is very important, this particular formula is extremely important. Now let's come to the periodic property. It is another important part. A function is periodic if it repeats itself for a particular interval. The interval should be greater than 0 in its domain. Okay, so in this case we can write this like this. So for periodic property, these 4 properties are very important. First of all, 0 to nt, t is the period of fx. Suppose for sin x the period is 2 pi, for cos x period is 2 pi, for tan x period is pi, for mod x it is non-periodic because it is not getting repeated, for fractional x period is 1 because after 1 it repeats itself. Okay, so 0 to nt, so n 0 to t, a to a plus nt, so n is outside, so 0 to t, a plus t, or 0 to t, and a plus nt to b plus nt, a to b fx dx, so mt to nt, so n minus m in this way. So for example, I am showing you one application of the periodic function, and these properties, these 4 properties, there are a number of properties, but these 4 properties are very important, just remember this. So let's calculate. Sorry, 0 to 1000 e to the power x minus box x. X minus box x is fractional x, and for fractional x periodic, remember one thing, for fractional x the period is 1. So 0 to nt, 0 to 1000 into 1, so I am taking 1000, 0 to 1 e to the power x minus box x, which is fractional x. Now we can write 1000, so between 0 and 1 box x is 0, so e to the power x, so e to the power x is e to the power x, so 1000 e minus 1. This is the final answer. Where is that? 1000 e minus 1 is the answer here. Let's go to the next sum. Suppose this is the sum 0 to pi, 0 to 100 pi, root over of 1 minus cos 2x. Root over of 1 minus cos 2x is what? So 1 minus cos 2x is 2 sin square x. So we are getting here 0 to 100 pi root over of 2 sin square x dx. So root 2 is coming out, and we are getting here 0 to 100 pi root 2 mod of sin x. And this is a mod x periodic. 0 to nt, the period of mod x is pi. So 0 to nt, 100 is coming outside, root 2 is coming outside, 0 to pi mod of sin x. And what is the mod of sin x between 0 to pi? Between 0 to pi mod of sin x. This is coming 2, this area is 2. Okay, so 100 into 2 into root 2. In this way we can apply. So periodic function for the examination is very important. Now let's go to the next sum. So everyone, generally the properties related to the inequality is for JEE Advanced and for ISI examination. Then also the type of question which are coming in JEE Main examination and BITSAT examination. So let us prepare for that. So in this case, just see one thing. First property, if fx is greater than 0 on a to b, therefore for a to b, this is b, for a to b, fx, obviously if fx is greater than 0, fx is greater than 0 means the curve is above. Okay, the curve is above, therefore obviously it is greater than 0, area is positive. The curve is above the x-axis, therefore the area is positive. Now if fx less than equal to gx, then integration is nothing but the area, and between two of them the integration is the same. Okay. So, if gx is greater than fx, then in between the same interval, so integration of gx, the area of the gx is greater than the area of fx. Okay. Next, number 3, same type of thing, this greater than part, f2 greater than f1, f2 greater than fx greater than f1, then a to b, if we just apply, same thing. If the area is greater, if one area is greater than the other, then if we just apply the interval, the function is greater, then the area is greater means what, everybody? Greater means it is y is above. So the shadow of the y on the x axis is greater, obviously it is the area. Next, if the absolute maximum and minimum value of fx is capital M and small m, then integration fx is between small m into b minus a less than equal to capital M into b minus a. So remember this, and so everybody, this is a mistake. Total area we are taking between a to b fx dx. If we give the mod of this, if we give the mod, so this is coming inverted, this will be inverted if it is of this type. So obviously this area, this is the area, this area is more than this area, because here negative is working, but here all are positive. So we are using the sign. Actually, what is the definite integral? Definite integral is the area with the proper sign. Okay, let's go to the next one. If at every point x of an interval a to b, everybody, what is x? Remember one thing, what is x? X is the variable, x is between a and b, in this case any number between a and b. So remember one thing, if every point x in the interval, the inequality is fx lying between gx and hx, therefore their integral is also in the same place. Okay. The proof is this. Suppose fx is between gx. Actually, everybody, fx is between gx and hx. What is the meaning of this? The height of fx is greater than, what is there? The height of fx is greater than gx and less than hx, like this. The height of fx is greater than gx and less than. So accordingly, their shadow of the area also will be in the same pattern. Okay. So in this case, everybody, just see one thing. This, the area of fx is this. This is the area of fx. So this is lying between area of gx, this is the area of gx and area of hx. Okay. So let us solve this sum using the property. In this sum, x lying between 0 and 1. Remember here, this is the lower limit, upper limit. So x lying between 0 and 1. And denominator, whatever root over or whatever there, denominator is a positive quantity. Therefore, in this case, we can write this as x to the power 8 by 4th root of 1 plus x to the power 11 must be greater than 0 and less than x to the power 8, because some positive quantity is being divided. For example, we can say here that suppose 5 by 2 must be less than 5, like that, because denominator is a positive quantity, and remember x lying between 0 and 1. So we can just give the integral 0 to 1. So this is 0 to 1 integral, and we are getting here, this is 1 by 9. So this is the matter. Now we will go to the next sum. Let's solve one interesting sum. So in this case, I1 equal to integration pi by 6 to pi by 3 sin x by x. Similarly, the same integral, that upper limit, lower limit same, and this is the function is the sine of sin x by sin x, sine of tan x by tan x. So which is greater and which is lesser. So really these type of sums are very important, and in this type of sums we can always very important for the entrance examination. So let's solve by some another way. We can solve by area method. So here let us solve using increasing decreasing function. So first of all, fx by x, fx equal to sin x by x is the decreasing function. So how we can say that this is the decreasing function? So we know that fx equal to here sin x by x. So remember one thing here, if f dash x is less than 0, the function is a decreasing function. So let us get the f dash x. Here if we apply the f dash x, this is coming x square. So u by v formula b. So sin x is cos x minus x, this is sin x. So everyone, this is the less than 0. What is the reason behind it that this is the coming less than 0? Because sin x greater than x cos x. So how we can say? How to test this, that this is a greater than less than? So in between pi by 6 to pi by 3, let us take any one point, suppose pi by 4. Pi by 4 is between pi by 6 to pi by 3. So if we take pi by 4, let us test sin pi by 4 1 by root 2, which is greater than x is pi by 4. Pi by 4 is a fraction because pi is approximately 3.14. So pi by 4 is a fractional number and cos. So everyone, we can say here that sin x is greater than, so this is the negative. So the function is the decreasing function. So this is coming down. Now we can say here that sin x by x, but it is a positive quantity. So tan x greater than sin x. So if we just keep it in the denominator, sin is getting changing. Okay, it is getting changing. Therefore, we can say I2 greater than I1 greater than I3. Now let's go to the next. Next property, if m is the least value, that is the global mean, and capital M is the global max, then this integration fx greater than m into b minus a. So listen, so obviously it is. So just I am explaining you, I am trying to explain. Suppose this is a function fx, this is a to b, this is a and this is b. Therefore, suppose this is a small m and this is the capital M. Just I am explaining you. This is the simple explanation because global mean, global max. So I am not going to the maximum minimum case, just I am going to explain you. So obviously everybody, this area must be lesser than this shadow. Okay. So this is the calculation. Similarly, just see one thing, it is a proof of this. This proof is okay. Let's go to the next one. Next property, and this property is very important everyone. This particular property is very important. Just see one thing, that total mod of the integral is lesser than the mod of the function. Just I am trying to explain you. Just remember one thing. What is the thing? Suppose if a function is like this. So this is a and this is b. Between a to b, this portion is negative. But if the total function is above the x-axis, mod fx means it is above the x-axis, it must be greater than the this outside mod. Remember, this is very important. I am giving you just one example and instead. So this sum is 10 to 19 sin x by 1 plus x to the power 8. We have to get the absolute value. Absolute value means what? Just it is less than greater than what? So between 10 and 19, 1 plus x to the power 8, because x lying between 19 to 10. And remember one thing, this x greater than equal to 10, that mod of sin x, obviously always mod of sin x is less than equal to 1. So remember one thing here, so 1 plus x to the power 8 is greater than x to the power 8, which is greater than x to the power 10. X is, if we take the minimum value, now 1 by 1 plus x to the power 8, which is less than this. Now I am just 1 by 1 plus x to the power 8, which is less than equal to 10 to the power minus 8. Just put the value and we are getting the result. Now let's go to another, just one more important sum. So everyone, this greater than less than, this inequalities values are not very much important for the JEE main, but it is extremely important for the JEE advanced. Just see one thing, this is the one very good sum. So dx by root over 4 minus x square minus x cube greater than pi by 6 less than pi by 4 root 2. So in this case, x cube, x lying between 0 and 1, it means x is a fraction. X is the fraction. So fraction, it means it's about x cube less than x square. For example, x is suppose half. x is half, so half cube less than half square. Okay, therefore if we add x square on the both side, now just if we add minus, then sign is getting changed. We are adding 4, so if we add 4, so the same sign, now we are giving the root over this is, so I am just changing the color, it will be easier for to understand. So we can say here this is the root over. If we do 1 by, just same way, if we do 1 by, then sign will be changed, and this is coming root over, again printing mistake. So here if we calculate, if we take root 2 common, 1 just sin inverse x by a formula, and here also one printing mistake, here it has been, this is the integral, I am writing I here less than pi by 4 root 2. So all integral formulas I have given here, you practice and practice from this integral in one place, you got the whole integral. So everybody, I'll just make this type of videos and subscribe my channel.